Okay, let's talk about PARCA Technical Section 4.5, which covers pixels, voxels, matrix, spatial resolution, contrast resolution, and time resolution. A pixel is the smallest unit of a digital image or graphic that can be displayed. When we see graphic images on digital devices, the display divides the screen into thousands or millions of pixels arranged in rows and columns. Think of like an Excel sheet there. Each pixel has its own address in this grid and is represented by dots or squares, and that grid is called a matrix. The number of pixels used to create an image is often referred to as the resolution. The intensity of each pixel is variable. In color imaging systems, a color is typically represented by 3 or 4 component intensities, such as red, green, blue, or cyan, magenta, yellow, and black. A pixel channel. Color digital images are made of pixels, and pixels are made of combinations of primary colors represented by a series of code. A channel in this context, each channel represents a color. So a red, green, blue image is a 3-channeled image because it has 3 channels, and I think this graphic will help make a lot more sense, right? So to make this 1 pixel, so that circle here, the circle is 1 pixel, we'll say, it has a red channel, a green channel, and a blue channel, and you know how the intensity of the red, the green, and the blue can make it be red, can make it be green, can make it be blue, can make it be yellow. It can, by varying the different amounts of intensity in the red, green, and blue, you can make this 1 pixel show as different colors. Voxels. A voxel is the unit of graphical information that defines a point in 3-dimensional space. Whereas a pixel is a square, a voxel is a cube. So voxels are used when we're talking about 3D imaging. If the image is 2-dimensional or 2D, we're talking about pixels. Once it becomes 3D, now we're talking about voxels. So medical practitioners and researchers are now using images defined by voxels and 3D software to view X-rays, cathode tube scans, MRIs from different angles and effectively see inside the body. Voxels work exactly the same as pixels in terms of resolution and color. So the matrix I talked about earlier, an image is an array or matrix of square pixels. Pixels stands for picture element, arranged in columns and rows. Again, you want to think Excel spreadsheet here. In an 8-bit grayscale image, each picture element has an assigned intensity that ranges from 0 to 255. A grayscale image is what people normally call a black and white image, but the name emphasizes that such an image will include many shades of gray. A normal grayscale image has 8-bit color depth, which equals 256 shades of gray. They say grayscales in PARCA language, it's just shades of gray. A true color image has 24-bit color depth. That's 8 by 8 by 8 bits, or 256 by 256 by 256 colors, which equals 16 million colors. So let's take a look at that image matrix. Right, so if we took this little bit of this image right here and blew it up, you would see it has grays and other grays and darker grays and blacks. And there's a white down here. All right, so here's a black in this corner, and if you look at the value, you see that the intensity value is 0. That matches black. This is a white, and you see the intensity value matches 255. So zeros, wherever you have zeros, you have black squares. Technically, there's only a couple of white squares here, right? So this one and this one are white squares, and they're 255. So 238 is a shade of gray. So that's what the image matrix looks like. That's what those numbers mean. That's how that works. Let's talk about resolution. In terms of digital images, spatial resolution refers to the number of pixels utilized to construct the image. Images having higher spatial resolution are composed of a greater number of pixels than those with lower spatial resolution. In radiology, spatial resolution means how easy is it for you to differentiate between two nearby objects. Okay, so where does the edge of the heart end and where does the beginning of the lung start? Where does the end of one bone end and the edge of the next bone begin? need to be able to differentiate between two nearby objects. So more pixels crammed in gives better resolution, and again, I think a picture here will really help us all understand. So you can see on the right you have not very many pixels, which gives you low spatial resolution. It's hard to distinguish structures, but if you go all the way to the left, you see high spatial resolution. You can now distinguish what's roads, what's forest, what's buildings. More pixels, better resolution, better able to see details in the image. Contrast resolution. Contrast resolution is the ability to distinguish between differences in intensity in an image. Just like those numbers where you have a 238. If you put a 238 next to a 236, you're going to have a hard time seeing the differences in those two shades of gray. They're just too close in intensity value. Contrast resolution in radiology refers to the ability of any imaging modality to distinguish between differences in image intensity. So in this graphic down here, there's actually 6 boxes. There's 1 box, 2 box, 3 box, 4 box, 5 box, 6 box. And inside each of those 6 boxes is a gray square. So you can probably make out 1, 2, 3, maybe 4 boxes, but 5 and 6 you can't see because there's just not enough of a difference in their intensity for us to be able to look at it and see those little boxes inside the bigger boxes. And finally, time resolution, more commonly called temporal resolution. Temporal resolution is the ability to resolve fast-moving objects and is comparable to shutter speed for a camera. And for most medical imaging, that doesn't make any bit of difference, right? A hand is not going to move. You tell the patient to put the hand down and keep it still, and there's no motion inside a hand that's going to mess up your image. But when you're imaging the heart, which hopefully is always beating, now you have motion to deal with. So whenever you're doing cardiac imaging, you need to set up the scan in such a way that the images are captured very rapidly, so you minimize the motion of the heart, and you can see the structures, particularly the coronary arteries around the heart. So that's what time resolution or temporal resolution is. If you don't resolve temporal resolution, if you don't set up the scan to be quick enough, you're going to get a blurry image. And so temporal resolution does have an influence on spatial resolution, because if things are blurry and moving around, you end up with an image that looks like it has low spatial resolution when really you just didn't solve the time resolution problem. Okay, thank you for watching.